Good day. We are now on our third method in probability sampling. Okay, the first one is we use or we discussed a simple random sampling which consists of lottery and simple random number. We have also discussed the second method, which is the systematic sampling, wherein we use a formula f of p is equal to s plus k times p to generate our respondents or members of um, uh, the interviewees, or say, yeah, the members or the respondents. Now, in this video, we will be discussing stratified random sampling. We have two different methods under stratified random sampling. Let's discuss the two. In stratified random sampling method, we divide the population into what we call strata or non-overlapping groups. Okay, we group them into strata. One group is called the stratum. Now there are two variations of stratified random sampling. One is drawing random sample with prescribed random size from each stratum independently. The second is to determine the sample size for the whole sample and allocate the proportion of each stratum to determine their sample sizes. In short, method A, we require specific or fixed number of participants per stratum. So say for example, if there are four strata in our data, and we need 40 students, no, for our samples, then we allocate 10 students per stratum. Okay, so if that's the year level of students, so there are four stratum, first year, four strata rather. First, the first stratum is for the first year, then we have second year, third year, and fourth year. So since we need 40 students, no, as our respondents, so that means per stratum we need 10 students. So that's method A. However, method B calculates the proportion. No, that's based on the population, the total population, and the population per stratum. So say for example, the number of students in the first year is 100. For second year, we have 200. Third year is 50. Fourth year is 10. So we'll get the proportion based on or with respect to the population per stratum. Anyways, we will be discussing these in the next slides. So let's start first with method A, which is the simpler one. So say for example, we have 412 CSAIA students and we only need 80 students now to be our respondents. So what do we do? Now, let's just say that there are still fifth year students. Okay, so this will be our data. So the total population of CSEA is 412. Now 105 of which are first year students. So this one is our first stratum. Now the first year students first year is our first stratum. Our second stratum is for the second year, and so on. So if we say that 105 students are in first year, 95 are in second year, 70 are in third year, 80 are in fourth year, and 62 are in fifth year. Since we need only 80 students in method A, okay, what will we do? So recall that in method A, we will be uh, getting a prescribed random size or a fixed or a constant value for all of the stratum, which means that these five stratums will have the same sample size. Okay, so how do we do that? Again, each row is called a stratum. There are five strata. Now, to get the sample size for each stratum, we use this formula. N, or the sample size, divided by K. Now, this 5 year is the number of strata. So, since we need 80, okay, since we need 80 samples or 80 respondents and divide it by the number of strata, Okay, since we have 5 strata, and that's 80 divided by 50. And the result is equal to 16, which means that each stratum needs 60 respondents or students. We will get 16 rather. We will get 16 from each of the stratum. And if you check, you add all of these, no 16 plus 16 plus 16 plus 16 and plus 16, that's equal to 80. So we now have the list, the number of students. Then how do we determine these respondents? Now we can then use the other or the previous sampling techniques which discuss. We can have convenience, okay, or we can use simple random sampling or the systematic sampling. So it depends now on us. However, if we want that our result or data will be as reliable as possible, then we use random sampling techniques or probability sampling techniques. And that is method A. In method B, again, we will make use of what we call a proportion. Okay, and the proportion will be calculated using this formula n sub k, which denotes the stratum size, meaning the population per stratum, and divide it by the total population. Okay, that's uppercase N. So here we have different stratum sizes for each stratum. So our n sub k will have different values also. Then our n is constant all throughout here in this problem, and that's equal to 412. Then after that one, the stratum sample will be the proportion multiplied by our target random size. Okay, so our random size here is 80. So we need 80 students. And we multiply 80 by our calculated proportion for each stratum. Now, here, recall that P sub k, again, lowercase p sub k is equal to uppercase n sub k, which is the stratum size, divided by n, no uppercase n, which is our population. So the stratum size for stratum 1 is 105. Divide it by 412, which is our population, and that results to approximately 0.255. Then we'll proceed to the second stratum, which has 95 stratum size. Divide by 412, we get 0.231. And we get 0.170 for stratum 3, 0.194 for stratum 4, and 0.150 for stratum 5. Then we will solve for the number of samples per stratum, and that is the proportion. So n sub k, so uh, 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 if you recall our formula, n sub k is equal to p sub k multiplied by n. Now, if we are calculating for the first stratum, so that will be n sub 1 multiplied by p sub 1 is equal to rather p sub 1 times n, which is 80. So here our p sub 1 is 0.255. Okay, multiplied it by our target number of samples, which is 80. And that's 20.4, approximately 20.4. Let's do the same process. Multiply P sub 2 by N. So our P sub 2 is 0.231. Multiplied by N, we get 18.48. Perform the same operations to stratum 3, 4, and 5. So we get 13.6, 15.52, and 12.0 respectively. However, we have here, if you observe, we have decimal values. Now we don't have respondents, which is zero point 0.4. Let's say, for example, if these are people, No, we don't have a zero point 0.4 people. No, we only, these are discrete values. So we have either one or two persons or one or two respondents. So it can either be 20 or 21. But which do we use, 20 or 21? So we will round them up. Okay, rounding the numbers, we get 20.4 when rounded off is 20, 18.4 when rounded is 18, 13.6 when rounded off is 14, and 15.52 is 16. Then we have 12. Now we will check if the total of these n's, no n sub k's, is 80. So we have 20 plus 18 is 38, plus 14, that will be 52, plus 16, that is 68, plus 12, then we get 80. However, if it goes beyond, no, 80, say we get 79 after rounding, or 81, then we have to adjust. Now which of these rows or stratum will be adjusted. Now you can have, if the result here is 79, then you can adjust this one. Now 18.48, adjust it to 19. Okay, so that's an example. No? If again, if it's not exactly equal to the n, okay, the sample size. So that is method B. So I hope you understand methods A and B for stratified random. The last two sampling techniques are cluster and multi-stage sampling. Now, these two are can be performed with the combination of the other sampling techniques. So we can have a combination of stratified and systematic and so on. So cluster sampling is used, and also multi-stage. Now, these two are used when the population is very large. So we have to classify all members into several groups or cluster. Now, we call them clusters. Then perform simple random sampling, and all members from each cluster will be part of the sample. Okay. So again, this example of this is um, let's say surveys. No, actually surveys, they perform cluster sampling. For example, if you want to identify who or which presidential ball, um, well, the people vote for in the coming elections, then um, interviewing all of the people in all the regions of, or in all within the population of the Philippines, so it would take a very long time. So one common method or technique is through cluster. So say for example, I will divide them into clusters, which I call regions. Now for region 1, I will divide them into groups. Again, for let's just talk about region 10. So since we're familiar with region 10, now in region 10, I will divide them again, probably, in provinces. So I have Lanao del Norte, I have Misamis Occidental, I have Misamis Oriental, and we have the Bukidnon, the Camiguin province, and which I forgot. I think that's all. So that's divided into clusters. Then I will select, no, I will randomize which among, say, I have 5 provinces, so I will perform random value. So if I select 3, so that 3 there, say 3 is assigned to Camiguin. So my samples will be from Camiguin region. So from that cluster, okay, from that group. Now, multi-stage sampling is also the same, usually used for very, very large population and a very wide area. And I think my example there is can also be an example in multi-stage sampling. Again, these two are just um, for large population, but multi-stage sampling would take much larger population compared to clusters. Okay, and that ends our discussion that ends our discussion in the different sampling techniques. So our next lesson is determining the sample size of based on our given population. So therefore, see you in the next slide.